We're going to take a look at our next section in this video from Unit 2, Chapter 7 on quadratic functions. What we're looking at in particular here is Section 7.1, exploring quadratic functions in the standard form. And our objective is to, as we say, explore the functions so that you will understand how they behave and have some ideas of what to expect from a quadratic function in standard form. Vocabulary will be the same as what we did when we studied the vertex form. We're still going to be interested in the vertex, the axis of symmetry, maximum and minimum points, and the domain and the range. First, in class, we started with a real-life problem to help us recall what we had learned about the vertex form and to be able to see its usefulness in a real-life application. We looked at the following illustration of a bridge. It's a suspension bridge in Tacoma, Washington. And of course, you can see that there's a parabolic shape that's being formed by the suspension cables. If we look at it and consider this parabola that we're looking at, we can see that, well, A is definitely going to be greater than 0 because it's opening up. And it looks as well as though the A will be a fraction because it's very wide. It's open, a very, very flat parabola. So we're going to look at two particular questions. How could we use a quadratic function to measure the height of the suspension cable above the roadway at its lowest point? So if you think about what's happening, I want to know how far above this is it? Now, as soon as you see that, you realize, hey, it's going to have something to do with the vertex. The second question that we're going to look at is, how can we measure the distance between the two supportive pillars? Once again, the vertex is going to come to our rescue. So let's take a look at some of the numbers and focus on the vertex a little bit. Now, just looking at the equation, do take some time to read this question, but looking at the equation, you can see, sure enough, A was positive, and it's definitely a small fraction. No surprise. We can see the vertex is 1400, 27. So let's take a look at what it might look like. I've drawn a really simple drawing of this one. Here are the two pillars, 307 feet tall. I've got a parabola that dangles down between them of a vertex of 1400, 27. Now, I have chosen to put my x and y axis here at the corner so that I have a good point of reference. And so, if I think about the distance between the two pillars, I know that halfway is 1400, so and all the way would be 2800, 1400 times 2. And then I can see if this is my roadway, then my cables are definitely simply 27 feet above the roadway at the middle point or the lowest point. Okay, now let's move on and look at the standard form of a quadratic function. I like to say that the standard form is a bit of an example of how mathematicians are accused of being OCD. They tend to want to have their ducks in a row. The standard form puts all your variables in descending order. X squared, x to the power of 1, and this would be x to the power of 0, which is really just 1. And then we have numbers in front, so you've collected everything. You don't have things spread out all over the place. Everything is together, organized, and neatly placed in the standard form. Now, what we want to take a look at is what happens when we start to play with the equation a little bit and start to change the numbers. So for instance, here's a quadratic function. What if I start to change the first number, the a value? Notice it's still an A as it was in the vertex as well. So what happens? So let's take a look in the graph. So here's my original, he's in red. And then when I did the -2, it flipped over the x-axis, so it's upside down. And you can tell it's a little skinnier, which you would expect with a 2. Here it's a -1/2, so it's going to flip over once again, so that's the green one, but it's a little wider than the original red graph. The purple one, multiplied by 3, is still opening up, but he's skinnier, which is what we would expect as well. So in conclusion, it's the same effect as the A that we saw in the vertex form. If A is a negative number, the graph is reflected over the x-axis. If A is greater than 1, the graph is skinnier or more narrow, and we call it expanded here. Basically, it gets higher faster. And if the number is between a 0 and a 1, so a fraction, then the graph is squished down. It's open wider, as we had with the vertex form. So what happens if we play with the middle number? Now, this one's a little bit strange. It's a little bit harder to see. Let's take a look at these. Here's your original in black. Now, When I take a look at the original and think about where it is in relationship to 0, 0, I realize that it was a 3x and it moved over, the vertex has moved over to the left. When it was 2x, it moved over to the left, the red one. But when it was negative 5x, the blue one moved over to the right, the vertex moved. And when it's green with a negative 4, it also moved to the right. Now, it doesn't seem to be moving in the exact same way. If you look at, let's see, with negative 4, let's say, it's moving over to the right 4, but it didn't move 4 over, it moved 2 over. And then when it was minus 5, it moved 2.5, and so on. So we come to the conclusion, it's rather a vague one, but B, what does B tell you about it? Well, B seems to move the graph left and right and a little bit up and down, but in the opposite direction and at a smaller rate. So it's moving at less than what the number is and in the opposite direction you would expect. Now, actually, I'm going to go back to that example for a second. I want you to notice something about all these graphs. All of these graphs pass through a y-intercept of 1. And if we look at what we have in the end here, we have a 1. It seems almost as if that last number might be something about the y-intercept. So let's take a look at this last one, where I've kept it the same, but changed the last number. Let's look at it. This purple one, did it go through as a y-intercept of 1? Sure it did. How about the black one? Through at 3? The red one at negative 2? The blue one at 0? So in conclusion, we can say that the value of C tells us the y-intercept. So the one last thing that I'd like you to see, we think about graphs in the standard form. It's easy to find our y-intercept. We can also see A. B is a little bit hazy. We're not sure. It's a little bit harder to find that vertex in this form. Let's take a look at a couple of questions and try to predict what our values are. Okay, in this first one, well, we can tell that A is greater than 0 because it's opening up. It does look a little skinnier, but we don't know for sure. And then we look at B. This vertex has moved over to the right, so it seems like B is probably negative, and C is 1. So for the next one. This time, it looks like the A is definitely less than 0 because it's opening down. The vertex has moved again to the right, so it seems like it's probably negative, and C is negative 3. The last one, once again, it's opening up, so the A is greater than 0. It's moved to the left, so it seems like B is probably positive, and our y-intercept is negative 2. Now, I'm going to take this one actually and test my results. And what I'm going to do is take this graph and create an equation. I have a vertex of negative 1, negative 3, and I have a y-intercept of negative 2. So let's go ahead and work on that. Negative 1, negative 3. Okay, here he is plopped in, putting the apples back in the tree, so to speak. And he went through 0, negative 2. So I plug in those numbers. And if I do my work, I find that A is just a 1. So my equation looks something like this. Now, this is not in the standard form yet, so I'm going to expand it. I'm going to do this squared. So then I FOIL everything, multiplying everything by it, so I get x squared plus x plus x plus 1 minus 3. When I clean this up and put it in descending order, I end up with the following equation, I should say. This is the function in vertex form, and this is the function in standard form. And sure enough, the A, like I predicted, is greater than 0. The B is positive, and the C is negative 2. So my predictions were correct, and I can see now sort of the difference between the two. Vertex form, which lets me find the vertex easily. Standard form, which lets me find the y-intercept easily. Both of them give me some idea for the A's, but this B, it's impossible, really, without a little bit of work to find our vertex. We will talk about it in the next lesson, so you'll know how to do it. But as you can see, these different forms have different strengths and different weaknesses, and we use them for different purposes. So there you have it. That's the quadratic function in standard form with a little bit of a review of the vertex form. Good luck with your homework, and make sure you bring your questions to class.